Welcome, everyone. I'm here with our esteemed guests today, Gerald Sussman and Julie Sussman and Chris Hanson. And Gerald Sussman is a professor of electrical engineering at MIT and has been for a long time. And his wife, Julie, famously also worked with him on the seminal work, Structure and Interpretation of Computer Programs, which was my introduction to computer science. And Chris Hanson has also been teaching with Jerry at MIT for a long time, and has also been working on the MIT scheme system and lots of other things. I don't know Chris very well, so I look forward to hearing more from you.
Alex,
So
will it mess up your recording if we interrupt and make corrections so you can?
no, please interrupt.
So Chris does not teach with Jerry at MIT. Chris lives in California.
Okay.
Well, I did teach with
He
Jerry
did teach
for a
with
couple
me.
of years.
Right.
We
But he worked
started-
at MIT with me for 26 years.
Yes,
How's that?
As a
Excellent.
system wizard.
Yes, as
I
the
also-
system wizard, basically.
I was the original designer and still maintainer of MIT scheme. So
Right.
yeah,
So yeah, my main two-part question for you, Chris, is what is the best programming language and why is it Scheme?
oh geez,
So you
yes.
go
Well,
with
the
it.
best programming language for what? That's really the question, right?
I agree.
there's a lot of different languages.
Of course.
I have written many, probably close to 1 million lines of C. I have also written close to 1 million lines of Scheme, and I like them both for their, well, C I didn't used to like. These days I do, because the standardization effort has really paid off and made it a much easier language to use. And Scheme, Scheme is just wonderful because it's so easy to write in, useful and interesting programs and make them readable. And that's a big deal. Being able to write something that is readable and is very direct and has just the right amount of abstraction is really a great thing. However, since I'm commercially employed programmer, I program mostly in other languages. And lately I spent a bunch of time at Google writing Java code, and more recently at a startup writing C++ code, which is, I really didn't want to learn C++, but I did learn it, and it is usable if you're extremely disciplined and careful. But beyond that, yeah. So Scheme is great because there's hardly anything to it.
The right answer is that it's a language which does not have a lot of ceremony. When you think about Java, you have to basically bound scrape to the author of the compiler
Well,
to get it to work at all. Okay, it's
less than it used to be.
but yes, but it's a ceremony-full language.
That's right.
And the Scheme is the exact opposite. It has essentially no ceremony.
Right.
Okay? And that means if I want to express something to tell students how to do something, how to think in this style, okay, it's easier to express an idea in a very simple language than something that's very complicated where you have to start thinking about the language too. So
Right.
for the purposes of expression, something like Lisp in general and Scheme in particular is a winner. Okay. However you want to write a device driver, it ain't going to be there. You do that in C, right?
Right.
Yeah.
Well, also there's the standard thing that people talk about with other kinds of languages is that, the type safety and all that stuff. And that is, Scheme is perfectly type safe, but it's at runtime. And some of those type declarations, although they're quite tedious, can be very helpful in organizing your mind, right? When you're trying to build something and trying to design it, you can sort of use the type declarations as a way of saying, okay, this is going to be this kind of a thing, and so on and so forth. And in Scheme, you kind of have to keep all that in your head, right? It's like you know how things are going to work, but you can't write them down in an easy way, at least not yet. And that's one of the things that we've been thinking about is how you might, incrementally mix that kind of declaration into a Scheme program to help document it and make it clearer, but also to help, the compiler could look at it and say, oh yeah, so you made a mistake here, that kind of thing too, by using type inference and that. We talk a bit about that in our book even. So, we talk about type inference, we talk about generating user types, and how that stuff can help you write programs that are, without getting in your way so much, but they can still help you find find bugs in your programs and that kind of thing. So, that's one of the things, Jerry's right. Ceremony is important, but sometimes these other things help too. And there's no reason why Scheme can't do all of it, right? It's just a matter of work.
Well, the one thing you
Yep.
don't want is, I think, most languages require you to do things like put in the types. Okay, it's required to make it work. The nice thing about, again, the Lisp world is it works without saying that, but if you say it, it gets better. Okay, and so the point is that, again, it allows you to do anything you like. Okay, you can change the meanings of the primitive operators like plus. I mean, that's fine in most Lisps and Scheme included. But the thing that's nice is that even though you can do that, okay, you're not required to do anything. Okay, so it's sort of a libertarian version of programming. Okay, as for liberal
So-
types like us,
So in my day job, I work on closure with Ritchie.
Beautiful.
So also spend a lot of time in this space thinking about these same things. And as Rich often says, stop repressing me. Don't make me say all that stuff. I don't want to say all that stuff.
That's why
If you want to say it, it's fine. I just don't want to say it.
I like Rick. He's a really great guy. Yeah, it's exactly, that's true.
So why don't we go way back? 10 years ago, I emailed you and asked you if you were interested in speaking at Strange Loop. And you came out and did a fantastic talk. And it was a great experience. And your talk was called "We Really Don't Know How to Compute." And I went back and looked at some of that. And it seems like there are definite sort of through lines from there up to the book that you are coming out with today. It seems like it's very much in line with that.
Absolutely. That talk was a preview of what Chris and I were about to do, although we didn't know at the time we were about to do it. We didn't know we were going to write a book.
That was a little later, but
Right.
it was in line with, it was coming out of the experience of teaching that class,
Right.
which we started for a completely different reason, but turned out to be something very interesting.
Yeah, we could show you the book. The book cover. Do you
Sure.
see it? Well, this is the book
Excellent.
that Chris and I just produced. It's going to come out from MIT Press. Was releasing it on the 9th of March. Okay, amazingly enough. Unlike, I was really freaked out by that because I expected that when the books would be in the warehouse, we could just get them. They're already there, but unfortunately, Penguin Random House, who's doing distribution, actually doesn't release a book until a date, even though they have
Right.
them all in boxes in their, in their warehouse. And I
Right.
need them because I want to give them to my students now.
Mhm.
Yeah.
But it makes you feel very special, like a Harry Potter book, it can't be sold. Well,
Well, I've pre-ordered it. I'm waiting for my copy too. So,
So there it is. It's full of lambdas, of course, as you can see.
Of
It's not
course.
just for your amusement. I can shut that down again, stop sharing. Yeah, but it's full of basically things that we learned over the years, and it's actually not quite finished. That is that this is I've already learned a lot more since that book is finished. We finished this version, okay, so that we can do another version of it in a few years, and it'll be better. Okay, 'cause
Perfect.
I know exactly several places now where I can improve it immensely.
Yes, well, and plus, to be really honest about it, we invented a lot of the stuff as we were doing it. We figured it out and we wrote it down, and and so a lot of this stuff is really just sketches of ideas that we made them work, but yeah, they're not. The implementations are just okay, and they're not. They're not real in some sense, but they could be made real, and that's something that I'd be excited about doing. Jerry and I have talked about, how do we integrate some of this technology into MIT Scheme so everybody can use it, and that'd be really cool.
Yeah, so it's sort of basically hot out of the gray matter. Thinking
Mhm.
that way.
Yes, exactly.
Well, I
For
look
some
forward to
value,
reading it.
since it took us so many years to write the thing.
A book always takes 5 years.
Yeah.
Do you have can you give like a high level overview of the topics? Is
Well,
that
go ahead,
possible?
Chris, you want to?
Could read about
Uh,
the back of the book.
the topics. So yeah, so we have, what were the main chapters? We have a thing on, we call it domain specific languages. We have a book about a chapter on pattern matching. We have a chapter on what was it? The variations on an arithmetic theme, we called it.
Generic.
Basically,
Basically generic.
basically about genericity
Right.
and also about combinators and things like that. So that was a lot of fun. And then there's a chapter about sort of advanced interpreter techniques for building languages that are like Scheme but different slightly. So more flexible, more something or other, basically. And then finally we ended up with we had a very short chapter about this thing called layering, which we talk about layering both procedures and data so that you could do computations in parallel and basically add layers to an existing program to enhance it, like adding units or dependencies or what have you, to add functionality to the program. And then
one of my undergraduates is now telling me how to do it better.
Yes, he's thinking hard about fixing some of the misdesigns that we did. And also the propagation thing, which really was, it's sort of a vehicle for thinking about fine-grained parallelism, but it also was, we fell into this idea about how to do optimal dependency-directed backtracking, which as far as we know, no one has ever done before. So that was what we mean by optimal. That's complicated, but we do explain it in the book. It's more like what used to be called data flow machines. So, and it's really not taking big programs and so much as starting from the ground up. And also we built it, at one point we built a compiler from Scheme down to these little engines. That was kind of fun too. So I want to resurrect that one of these days.
So it seems like, Jerry, that you've used a lot of biological metaphors and things that I've seen. Do you think there's any that we're anywhere within sight of making things as resilient as biological systems?
No. We're still in the dark about this. Look, the most remarkable thing, it's truly remarkable. Your genome is a gigabyte. Okay. It's everything it takes to build you out of a single cell. Plus it runs you. Okay. It's a program that runs every cell, and it manages to also defend you against other guys who want to eat you, and you last about 70 years. That's amazing. And
it's pretty good.
And furthermore, it's super flexible. You change it a little bit and you get a rabbit instead. Yeah. Okay, that's it's only a little bit change. Most of it's the same.
Been introduced to some scary new attack vectors in the last year, but
yeah,
maybe not new at all, but more visible.
100 years ago too. So.
Yeah.
Yep.
Yeah, but it still works amazingly well.
Yep.
And this, and I think it's super dense. Only a gigabyte.
Yeah.
And super flexible. How do you do that?
I was going to ask, it seems like a lot of things that I've seen in the software design for flexibility and the things that I've seen about it online are about making operations generic and extensible. And you mentioned data in there. I was wondering like what your thoughts are on the importance of data and how we make data extensible in the same kind of way.
Well, that goes back to this layering idea mostly, although, I mean, part of it is an old story, which is the bundling of data and program together, which, is things like closures and objects and OOP languages and that kind of thing. So part of it is just merging the data into the program. But part of it, the layering thing sort of takes it in another direction. So instead of having, it allows us to basically add, so the primary thing we're trying to talk about is how you can take an existing program and adapt it without rewriting it. And so layering actually plays an important part in that, because if you're going to like, for example, let's say you want to keep track of how your computation is running. In, let's say you want to understand, why something happened. You could add a dependency layer or a justification layer or some sort of thing that would support explanations of why your program ran a certain way. And you can do that without changing the original program, just by, as long as you architected it in the first place to support layers. Or at least, it's easy to backport, to still run it with layers added, which we know how to do now. And that basically that has some nice effects, because then you can enhance your programs and add these, like I said, units, dependencies, any of those things that are related to the data you're computing with, but not actually directly, in the main computation.
So it's like metadata, basically.
That's right. In fact, the thing is, every piece of data and every procedure has its own metadata and procedures.
Yes.
Okay? And that potentially you can add to them dynamically.
Yes.
Okay? And that therefore, when you execute some piece of code, you execute the metacode as well, and the metacode has to correctly interact with the base code at every level.
But the
we have
interaction is quite weak, so which is nice, because the base code doesn't know anything about the metadata code, and the metadata code only knows a little bit about the base code. Like, for example, if you're doing arithmetic, you want to do treat zeros, especially in many cases, that kind of thing. They'll affect the metadata.
We have a metadata system enclosure like this that does some of that. You can't use it for everything, so that's the caveat there. You can't use it for numbers, but you can use it for collections and things like that.
It's a hard problem, and I think that we have talked a little bit in the book about one way of approaching it. But I think, as Jerry said, one of his students is trying to clean that up. And I think there's still a lot of more work to do there. I mean, some of the problems we put in the book were, I recall there was one where we were talking about, instead of doing the metadata just on the low-level operations, what if you wanted to raise it up to the next level and do it at that level, and that, and not do it at the lower level? And how would you go about doing that? And I don't actually know the answer to that. I'm not sure Jerry does either, but it's something that is interesting to think about and would be fun to work on. So.
Yeah, but the ultimate goal here is to make it so, for example, in the propagator system that we've talked about, even at Strange Loop, okay, there was a certain metadata that's carried along, which is the dependencies, okay, but that was done explicitly in the propagator system. Now we don't do that. Now we build the metadata on the primitive objects of the language, like addition and multiplication and things like that, and that is automatically inherited in the point we pull it to the propagator thing. The propagator thing is built on layered data. You see.
Or can be. It doesn't have to be.
It isn't the way we did it, actually.
Yeah.
So that's an example. And that
means
could have been done.
We separated those ideas out.
That means, for example, you could add other layer to the same stuff, and all of a sudden the propagator is doing it the right thing too.
Right.
Okay.
Well, I look forward to reading about it. It does seem like, I think we've done some related kinds of things in enclosure, so I'm really interested to see how that's different than what we've built. And
the amazing thing
like
I've just heard is that there's a gentleman, Sam Ritchie, who's been writing the SICM stuff in enclosure, and it's working well.
I have seen a talk by him about it. It's very interesting.
We've been talking about it because there's some complicated, funny cases, it turns out, in automatic differentiation, which the theorems, even by Mandjuk, etc., with Siskind and Perlmutter and Radul, that stuff doesn't quite cover it clearly. And so we've been talking about that, and of course we have the same problems as they do in our version of this, but they don't matter for any real case that I know of. I've actually put in a warning in my schematils code for for checking for it, and running all the old cases, including all the ones that Jack Wisdom has used for research, and made sure that this never comes up. But in any case, that really fixes a lot of interesting things. It means that we have a lot to study there.
It's
Good
clearly
one.
not well fully understood yet. I mean, we basically put in fixes to the differentiation stuff until we ran out of time. And I think there's probably been more since then. So,
There was one more that came through last July.
right. And I suspect there will be more in the future as
Yes.
well.
Right. Mhm.
Well, that's great. I also wanted to ask while I had you on the phone, Jerry and Julie, I know you came out for the eclipse in 2017 to the St. Louis area. And I was wondering if you had any good stories from coming out. I was fortunate enough that my house was in the path of totality,
Yeah,
so I just
the
went out in the
story is you
backyard.
got to see it because of where you lived, and we did not get to see it because of where we traveled to. So we did not see the eclipse.
We were the only the few people that clouded out.
It was
Ugh.
it's a long story, and it's not worth telling, but we did not. However, we did have a short visit to some things around St. Louis that was very nice. We got a chance on our first trip when we were at Strange Loop in 2011. We visited the Missouri Botanic Garden,
Mhm.
which is one of the really fine botanic gardens. But there's a separate part of it out of town. Why can't I think of the name of it right now?
It's Shaw is the
Yeah.
Shaw Park. Shaw,
And
yeah, Shaw Park, I think.
we happen to know the brother of one of the main people there. And so we went over there and he gave us a private tour of some of it. And so we saw some really nice
That's
things.
a
We also
beautiful park. Did you see any bluebirds?
I don't even remember now exactly what we saw.
They
But
are rampant over there.
we spent an extra day in St. Louis on that trip after the eclipse, and we visited the zoo, which is really one of the fine zoos. So we've seen some of what you have to offer out there. Yeah.
Well, I wish you'd just come over to my house during the eclipse. You could have just hung out in my backyard.
That would have been much better. If we had planned that, that would have been nice.
Well, there's another one coming up in a few years. You can stop by.
2024.
Uh-huh.
And the real good one and the right place to be is Austin, Texas.
Oh, good. It's coming near here. I think out a little east
No,
of
but
St.
the center
Louis.
of it's going to be in Austin,
Yeah.
Texas, which is also a drier place.
That's true. It's less likely to be cloudy.
Less likely. Although I was just unluckily got in the wrong place at the wrong time. At the wrong time or whatever.
Sorry to hear that. All right. Well, I'm going to wrap up now, and unless you have anything else you want to share or you want to talk about.
Well, nothing in particular, except that I'd very much like to come by again and visit you again. And Strange
be
Loop
great.
sounds like a fun thing, but we can't do it right now while everybody's worrying about this strange viral disease.
Yes.
Well, Alex is being an optimist and planning in case he can have it. So I hope it works out. I guess I would just say that going to your conferences has been a lot of, and related ones has been a lot of fun. Really going to Strange Loop was your first experience, Jerry, I think, of meeting people in that community.
That's right.
And that was very interesting and a lot of fun, great people.
Well, I had lots of great stories from people telling me that they got to meet you and had a great time talking to you. And it was funny because because Guy Steele had been out to Strange Loop the year prior to that. And for months afterwards, people would tell me similar stories like that they'd been out to lunch with Guy he's such a generous guy as well. And so,
He's wonderful.
yeah. And so
Well, of
it's
course,
been
when you
great.
invited Jerry to Strange Loop, he didn't know who's Alex Miller or what Strange Loop. Is this for real? Is this worthwhile? So he saw a guy had been a speaker, called Guy, said, should I do this? And Guy said, yes.
Okay. So that's why I did it. That's why I showed up. After all, Guy's an old buddy of mine.
And then as a result of that, going to
Mhm.
Lambda Jam in Chicago and
Uh-huh.
Closure Sync by Eric Normand.
Oh, right. Yeah.
Yes.
To all those places.
Well, Chris, I would love to have you out sometime as well.
Well, when
either
things
at,
are a little more normal, yes.
Yeah.
So when you invited us to St. Louis, I was actually very excited because we've traveled a fair amount. I mean, not as much as some people. And we've flown across the country many times, going to California, usually also Colorado, some other places. And I know the Mississippi. You know, I might take a little nap on the plane, look at my watch. Oh, 10 minutes till the Mississippi. There it is. You know, it's exciting to see. But I've never been on the ground near the Mississippi. I've never been on the ground in that middle of the country that I fly over, anywhere in the middle. So that was kind of special. And then Chicago, I remember I was very excited about the Chicago trip. And I was telling people, you know, we've just been on a trip to India and Singapore and Australia. I've been to China, I've been to Japan, I've been to Chile, I've been to Europe, but I've never been to Chicago. This is so exciting. And I wasn't kidding. It's really,
Chicago's
It's a great town.
I miss what's in
Yeah.
our own backyard there, and there's
Mhm.
stuff. So
Sure.
we are now more well-traveled because of you. Thank you.
Okay. Well, thank you very much.
Good to see you, Alex.
Good luck with your planning, Alex. I'll be impressed
Thanks
if
so
you
much.
actually can have
And,
an
and
in-person.
Well, I think we'll
if you
definitely do
do-
something.
If you
Okay, what was
do,
that?
It just might be different. Okay. Thanks a lot.
Bye.